Hello. Do I need the clicker thing?
Here you go. Wait for me to start.
So I shouldn't start pressing buttons. Should I stand over here? Seems good.
Yeah. Okay, so I think it's ready to just roll as soon as
Yeah, that seems right. All right, so I'm going to talk about something I've been working on at BitPay for a while. So at BitPay, we generate a lot of invoices for merchants so they can accept cryptocurrency from their customers. And this is sort of our next generation of infrastructure that we've had to build out to make that more scalable. There we go. All right, so we're building tools to build blockchain applications that can be scaled. Some of the tools that we've got public and private key generation, some peer-to-peer message construction stuff. We've got some block explorers, RPC connections. All of this is used in our wallet infrastructure. So if you guys have used the Insight Block Explorer, that's all going to be talking to Bitcore V8, the thing I've been working on in the future. So Bitcore Node is to help us query the blockchain so we can see things, what's in block 105, what's the balance of this crazy address, which if you look up this one Vaynert guy, you should go check that out. It's a pretty crazy address. Is that good? This way, that way? Should I squat? Okay. Sorry about that. So to do that, we have to download the entire chain. So to find out all this data, we have to sync the entire chain and store it in a database. Yeah, that helps. So we've tried this a few different ways. Our last iterations used different ways of storing the data that was in the chain. This current iteration uses MongoDB. So previously we used LevelDB. If you guys are familiar with that, it's generally what the Bitcoin client uses. So I'm going to talk about why we made a new version. Because rewriting is a lot of work. Why would anyone do that? So full blocks, there's a lot to index, and after a certain size of indexing things, LevelDB starts freaking out. So basically, to give an example of what's going on here, say you're tracking 1 million Bitcoin addresses. So what you're doing is you're syncing the entire chain, and every time you see a transaction going to an address, you need to write that transaction down. You need to store the information that happened in that transaction, and you need to make it stored in a way to where you can quickly pull that information back so that you can construct transactions and actually use your Bitcoin wallet. So at BitPay, we've got millions of addresses. So we need to be able to store and query all of these addresses really quickly for accounting purposes. So what was happening is we have to roll a new Bitcoin wallet every few weeks because the Bitcoin core client will actually start to hang up if we just let it run with our invoice addresses. So we're trying to build this to sort of offload some of that from Bitcoin Core into a more scalable software that can handle these millions of addresses. So we thought, what if we could build a data store for Bitcoin that could sync quickly and handle millions of addresses without hanging up? There's some hard parts about doing that. So syncing quickly, previously it's taken an entire month for us to sync this indexed Bitcoin node. So we try to cut that down. Getting a wallet balance. So basically for Bitcoin, the way that it works is you actually have all these outputs. So every transaction, there's inputs and outputs. To get your balance, what you need to do is you need to add up all of your outputs that you haven't spent. So if you have a lot of outputs and they're not stored in a way where you can go through them very quickly, that can be really slow to get a balance. So we've tried to do some optimizations to be able to do that quickly. There's also a bunch of blockchains, and we would like to be able to interact with quite a few of them. So that was part of the design consideration. How do we plan ahead for that? So as for fast sync, basically when I say sync, what I mean is you ask the Bitcoin peer-to-peer network, hey, this is my current best block. What blocks do I need? It responds back saying, hey, you need these blocks. And you go and get those blocks, and then you ask the question again, hey, these are the blocks that I have. What blocks do I need? That's syncing at a high level. So we've gotten that down from a month to about a day if you have a really fast computer. It runs about 5 days on my MacBook, so that's a pretty big improvement. So as for getting a balance, so we actually had to change up our data model a little bit to get this to happen. So instead of storing transactions and tagging transactions with which ones are relevant to our wallet, we're actually storing just the outputs, and then the outputs are associated with our address. To get a balance, all you have to do then is query for outputs that haven't been spent. Who's still with me? So this is a really technical talk about Bitcoin. If you guys aren't familiar with how outputs and transactions work, this is probably like, whoa, what is this guy talking about? So this is a very simple example of a transaction. So we've got one input here and one output. So what we're doing is we're just storing the input and the output. Actually, it ends up just being this side of the arrow. So whenever this arrow is consumed in a transaction, we just mark which block that happened in. So we call that coins in Bitcore. So to get your balance, you just add up all of those coins. It's pretty cool. So for multi-chain, we actually have a pretty interesting way of handling forks, which is a fork happens like Bitcoin Cash. Let's think about that. So at Bitcoin Cash, there's a specific block height at which the chain forks. So really the only relevant data you need to sync Bitcoin Cash up until then are the unspent coins. Everything else is just transactions is all copied, same transactions happened. To get a balance on Bitcoin Cash, you really just need to start syncing those inputs that haven't been spent yet. So we made that optimization. That really sped up how fast we can download the Bitcoin Cash blockchain. In addition to forks, there's also like a lot of other chains. There's like Litecoin, Dash, Ethereum. All these other chains all have different data structures. And we would like for this to sort of enable us to store or be able to connect to all of these chains. So as a part of that design consideration, we made a formalized API that can be implemented for any chain. So what this means, you guys are probably like, what the heck is an API, formalized API, what's going on? What that means is that for each chain, we have a specific set of methods that we implement, like getting a balance, getting a list of transactions, finding what happened in a block. So as long as you can implement these things, you can actually just plug it in to Bitcore Node. And that's really cool because we have a lot of software that connects to Bitcore Node, like our wallet and our block explorer. So this is where we're at right now. So we've got Copay is our wallet, and that talks to Bitcore Wallet Client, which talks to Bitcore Wallet Service, which talks to Bitcore Node. It's quite a few hops there. But we've connected Insight directly to Bitcore Node. So what this means is very, very soon we'll be able to have our BitPay wallet and our Copay wallet talking to Bitcore, which if it's multi-chain, then that means our wallet will be able to be multi-chain as well, which is pretty neat. So we got synced down to 3 to 5 days. We've got better handling of Bitcoin forks. And we've got the architecture for more chains. We've got a uniform API, the same API for multiple chains. And since we switched to MongoDB, our throughput for processing these API calls has gone up like 100x. So our stuff is going to get a lot faster once we get this all worked in. Adding a new chain is as simple as just implementing one file, whereas before we'd have to go through the entire code base, find everywhere we're accessing certain things, figure out how to make it work for the new chain. So it should just be one file. For our wallet, we've got it to where we can handle about 10 million plus addresses, which in one database and not having to roll a new wallet every few weeks, that's pretty good. It's easier to add new currencies. Just like I said, it should only be one file to add a new currency. So that's what we're working on. We're trying to get the wallet BWS connected to Bitcore node. There's been some pretty major progress on that. This is all on GitHub, so if any of this sounds interesting to you, this is all happening out in the open, and you can watch it happen, or you can come and help make it happen. So I have an asterisk here. Insight is mostly working. I had to cut out a lot of stuff to get Insight to work, so we're still working on getting full feature pair with Insight working on Bitcore Node V8. Oh yeah, sure. So Insight's a block explorer. If you guys ever send a Bitcoin transaction and then you get a link that says, see here on the Bitcoin chain, that's going to bring you to a block explorer. And that's basically just a way for you to look at the data that's happening on the Bitcoin network and see, okay, in this block, these transactions were sent. Here's my transaction. I can see that my thing happened. So that's what we've got. Insight is our block explorer, and we've been working on getting that connected to Bitcore V8. So we've got some other chains. We've been testing what it would look like to have Ethereum support in Bitcore node. I've gotten pull requests adding Litecoin, and it was like 2 lines of code to add Litecoin. So it's pretty cool. If you have a coin that you like and it supports Bitcore lib, it should only be 2 lines. You just add that coin's Bitcore lib to this chains.ts file. We can talk about that after if anyone wants to support their altcoin. So yeah, this project's open source. If you like the idea of working on Bitcoin software, come and talk to me after this is over. So this is going to be even more technical than everything else. Awesome. Okay, so I'm actually going to show some code in here. So if anyone needs to close their eyes or whatever, that's fine. So we wrote Bitcore node in TypeScript, which is pretty cool. So if I break things, which I do very often, I break less things now because we have types. So that's cool. I'm excited about that. We've got an API for blocks, transactions, addresses, and fees. And if you make that one file that plugs in, the API will work for your coin as well. So this is how we did multi-chain stuff. All right, this is the code. Basically, we've just got some stuff for getting things for wallets, getting things for streaming transactions, streaming wallet transactions, a lot of things about wallets, and quite a few things about getting blocks and getting transactions. All right, this is the goal. So for Bitcore node, we really want to be able to handle any chain we want really quickly, and we want to sync really fast so that we can move our apps over to using this, and we can have a better developer experience. So at BitPay, we want fast turnaround for adding these new chains, less hassle for handling these wallets. We can't just roll a new wallet every few weeks. It's annoying. And we're trying to build some scalable infrastructure. So if that's interesting, let's talk. That's all I got. Any questions? Michael.
Hey, question recording.
Sure.
So you brought up a diagram that kind of had the flow of how you went from Bitcoin node or Bitcoin, maybe like Bitcoin before.
Right.
Can you go back to flip back like?
Yeah, so that was a slide or a diagram of how our wallet connects to Bitcore node.
I think that was it. What part of this is the sync process? What takes so long? What is the actual part that?
So the part that takes long about syncing is actually writing the data down from the chain. So Michael's question was, in this diagram, what is taking the time of syncing? And the answer to that for Bitcore node, specifically the one I'm on, is actually storing the data in Mongo, the database. So when you're storing things, there's indexes that help you find things very quickly. And the more indexes you have, the harder it is for Mongo to store the data in that way. So it's storing it in a very specific way so that it can be found very quickly. And that part takes a long time.
Quick follow-up question. So based on, the more indexes, the more useful the data. How many indexes?
That's a great question. Okay, so For transactions, we've got indexes on TXID, which is the transaction hash. We've got indexes on time things so that we can get sorted data really quickly. For coins, so the coins, when I say coins, it's the outputs. That one is our largest collection. So we've got billions of entries in there. There's probably 30 billion outputs on Bitcoin. There's like 700 million transactions. So on coins, we have an index on address, an index on wallets, so that we can find quickly the coins that are relevant to a wallet. And we've got indexes on things like transaction ID for coins, so that you can find all the inputs and outputs of a transaction. And then for wallets, you really just have only an index on the wallet ID. And then for blocks, we have a bunch of indexes on block hash, block height, various things. Anything that you would want to query by, that's what you would want to have an index on. I'd say all together, we probably have about 25 indexes across the collections. We do not have indexes on op return, no. So we do have, the script is stored on there. You could add a script index if you wanted to. Okay. Question? Mm-hmm. Are you asking if you could ask our wallet for blocks to make yours sync faster? Not currently. This would mostly be if you're trying to build an application. That would be a nice feature to have in the future, though. So we sync off of a fully sync. So the way that it works is we have a Bitcoin node that's already synced up. This is primarily for indexing it. So a Bitcoin node, you can download the blocks and store it on your hard drive without really any indexes, except like block height, and that's it. And then you ask it for the blocks, and then you index all these other things in Bitcore node. Sure, yeah. So right now, the collection that's the slowest for sync is coins, the outputs. But yeah, adding new indexes could either positively or negatively affect sync. It's actually a really careful balancing act where if we add an index to one thing, it might make it like 10 times slower. We have to test very carefully which indexes we add. Oh, sorry. Okay, so yeah, the question was, if we're recording all of the transactions, how far back do we go? Is that accurate representation? Okay. Yeah, so we start at Genesis block, height 0, empty database, and we ask for the very first block, and we continue that until we can't get any more blocks. So we start from the very beginning. Sharding, yeah, so sharded Mongo. So the cool thing about this is since we're on MongoDB, we can actually shard the database and run it on multiple hosts. When we're on LevelDB, we can't really do that. But yeah, that is a good point. Since right now we're at about 1 to 5 days, at some point this will be a 1 month long sync again, but Bitcoin will be much older then. We don't have sharding. We don't have it live yet, but what we're trying to do is get it to be syncing as fast as possible before we add sharding, because sharding will glaze over a lot of our performance failures. Oh, yeah. No, not a sharded blockchain. Sharding just from a regular database perspective. Sorry.
So what type of algorithm do you find the fastest parse through all the indexes and handle scalability?
Okay, so the question was, what sort of algorithm do we use to go through the database for scalable infrastructure? So a lot of that's actually abstracted away by the database we're using. So MongoDB, we just tell it the data to store, and it uses a B tree. As that answers your question. It's a B tree, and it rebalances the B tree based off of the indexes. Any other? Yeah. Yeah, we have a bunch of it. So the question was, how do we handle dust with millions of addresses? So we've actually got a few wallets that have been spammed with dust transactions. For this thing, it's the same as any other thing. It's not really affected by the amount of inputs or outputs that we have. Since it's all indexed based off outputs, like getting a balance or getting unspent outputs, we've got special indexes specifically for that. It's a partial index for spent height. So what we do is we have a spent height. If it has never been spent, it's in its own little set. So if it's something we can spend, then it'll show up in our balance. Otherwise, we're not really affected by it. Michael?
Take out the idea of like any kind of efficiency with sharding.
Mm-hmm.
What does this insight last?
Okay, so the question was take out performance gains cross chain. Yeah, so as for that, there isn't really much of a difference. In fact, there's actually less information, I would say, that our insight has currently versus previous iterations. So the question was, what has changed on insight besides performance gains? And the answer is not that much, but the gains would be the things that you mentioned: speed of API response and the ability to switch between multiple chains and networks.
Anything is using Bitcoin Core or Bitcoin Lib or whatever.
Bitcore Lib. Mm-hmm.
Bitcoin Lib would be easy to integrate in.
Correct.
What about projects that Ethereum or Monero?
Right, so that was that other weird thing that I had where it was a bunch of TypeScript code. So all you have to do in order to integrate into the API is create a file that implements this spec, a class that implements this spec, which has got various methods about how you get a block from the chain, how you get a transaction from the chain, and it will be serviceable by Insight and the wallet. It will not create an indexed form of that blockchain, but that's one way of handling coins that are chains that are not forked from Bitcore. The other way is we've got a way to create your own P2P interface for a chain and to register that as the peer-to-peer interface for a chain. And basically the only requirement for that to get data stored back on chain is that it emits, the peer-to-peer interface emits data in the same format as the others, as our internal state. So basically we have an internal representation of a block and a transaction. And as long as these peer-to-peer interfaces send the data back out as that, then it will get stored to the database. Okay. James. So the question was, why should you fork Bitcore and use it to do a thing? I would say you should fork it because it's got very drastically different performance capabilities than our previous version. And adding a new chain, if that's what you're interested in, is probably going to be easier in this version. And other than that, I think it's just a cool project to work on. Sure. So if you have something that requires on reading data from the blockchain, so a wallet, a block explorer, or say you want to see how many transactions per second the chain is getting, or things like that, you're trying to perform statistics or analysis on chain, this is probably what you would want to use. A lot of projects are trying to build different representations of data that's on chain in a way that can be queried so that you can learn things. So the whole idea is MongoDB is better than LevelDB for querying and doing analytics. Okay. Oh, that's a good question. So BWS. Oh, sorry. The good question that I said. He's asking which projects are using BWS, and the answer is most Bitcoin wallets. So that's a good question. So Bitcoin.com, I believe, is using BWS. So no, they're not using BWS. If they forked Copay, they're probably using BWS. Yeah, they're using BWS. Okay. Any other questions? Gabe. Yes. Sure. So the question was, why does Level DB have such a hard time? And why is Mongo better than it? So if your Level DB database hits a certain size, it starts doing this weird thing where it's thrashing and it can't figure out how to, and Gabe would know better. The guy asking the question would actually know the best answer to this since he dealt with it. But it starts thrashing and having a hard time. Yeah, it has a hard time figuring out where to put this data, and really the only thing you can do is make another level DB that tells you which level DB it's stored in, so that you don't have to try and put everything in one. Yeah. Gabe, does that answer your question, or do you have a better answer? Okay. So encoding the indexes, lack of developer tools, and what was the last thing you just said? Horizontal scaling. Yeah, you can't scale it. Mongo has that all built in from the genius himself, Gabe. Blockbook? I'm actually not familiar with that project. Okay. Mm-hmm. So that project, I'm not familiar with it, but what it's probably doing is just doing multiplexing to different chains, RPCs. They do have indexes too. It's probably very similar then. Yeah, this is written in TypeScript, yeah. It's cool. I'll have to check that one out. Any other questions? Oh man, if we start filling up gigabyte blocks, it's going to be really long to write those blocks down. So current level DB implementations, I don't know if anyone noticed, but during the stress test with just 17 megabyte blocks, it got really bad. So I think the Mongo version will have a easier time of storing gigabyte blocks, but yeah, syncing gigabyte blocks is going to be pretty crazy. They might need to adjust the block time. I don't know. For Bitcoin Cash? Yeah, if they start doing gigabyte blocks, they better switch over to a different data store, I would say. All right.
All right, thank you. Hey, so we have about 20 minutes to network, socialize, but then I'll kick you out. And we will be needing to go either, to Twin Peaks, or you can go home, but you can't stay here, right? However that phrase goes. So, and if you do want to go to the after party at Twin Peaks, it's the second floor, okay? All right. Thank you, everyone, for coming.